Yes, dear students, now today's topic is vector product or cross product. Vector product or cross product. In figure here, vector A and B are there, having an angle between their direction theta. So, how to define the vector product or cross product of any two vectors, say vector A and B, is defined as A cross B is equal to modulus A modulus B modulus A modulus B sin theta n cap. A cross B comes a vector which is product of magnitude of two vectors, sine of angle theta between the two into n cap. I am repeating, A cross B is a vector, one vector, whose magnitude is equal to modulus A modulus B sin theta and direction along n cap. What is n cap? Here n cap is unit vector whose direction is normal to the plane containing vector A and B. Here it is little lengthy and people feel difficult to understand. I am telling here A cross B, these are two vectors A and B. Their cross product will come another vector. A and B are two vectors here, whose cross product will come out another vector, and whose product is given this by A cross B equal to modulus A modulus B sin theta n cap. Theta is the angle between direction of two vectors. I have not completed this figure. Reason I will explain. So n cap is a unit vector. Why this vector is needed here? Because A cross B is a vector. Because A cross B is one vector and every vector has direction. So we have to define this direction also. So n cap define the direction of A cross B. Please be careful while listening and imagine what I am telling. After listening the whole video, after seeing the whole video, imagine what is the meaning. A cross B is one vector whose magnitude is modulus A modulus sin theta and direction along n cap. So here n cap unit vector whose direction is normal to the plane containing vector A and vector B, and is further determined using right-handed screw rule. Here I simply shown vector A and B and not shown direction of n cap. I have written n cap unit vector whose direction is normal to the plane containing vector A and B and is further determined using right hand rule. Why this is said here? Actually, here vector A and vector B are lying in plane of board. When you draw the diagram, you will be drawing on your paper, copy paper. So that A will be in your figure will be lying in plane of paper on which you are writing. Student, I have found very much confused about concept of plane. A and B here in my diagram are lying in the plane of board, and in your diagram it will be lying in the plane of paper. So normal to plane of board or plane of paper may have two directions, either outward or inward. Normal to the plane of board. Why? Because A and B are lying in the plane of board. So n cap unit vector whose direction normal to plane of containing A and B and is further determined using right-handed screw rule. It is right-handed rule, not right-hand thumb rule. If we place a screw whose axis is perpendicular to plane containing A and B, I will write here, but I am explaining here. What is right-handed screw rule say? If we place here a right-handed screw whose axis is normal to the plane containing vector A and B, and then rotate the screw from A to B or B to A, depend what are you telling. If you are finding A cross B, then you have to rotate the screw from A to B. Then screw will come out, move upward. So linear motion of screw will give n cap. Here A and B are lying in plane of board. So here according to right-hand rule, n cap should be normal to plane of paper and outward. So we can't draw line in the air here. So to show 3D, three-dimensional picture in two dimensions, this plane of board is two-dimensional. So we have taken a convention. Whatever is perpendicular plane of board outward, that is shown this way. So n cap is this way, and hence A cross B is this way. A cross B is a vector whose direction is normal to plane containing vector A and B and is further defined by right-handed screw rule. So what does the right-handed rule say? What does the right-handed screw rule say? So I will writing here, according to right-handed screw rule. According to right-handed screw rule, if we place a screw whose axis is normal to the plane containing vector A and vector B, and then rotate the screw in order of A cross B, that is from A to B, vector A to vector B, then linear motion of screw, linear motion of screw will be along N cap. So dear student, please, it is very important. In class 12 you will get a chapter of magnetism. Then there you will feel it difficult if you don't understand what is cross product. There are many topics in physics which can only be understood if we know what is vector product. So I told you the vector product of any two vector A and B is defined as modulus A cross B equal to modulus A modulus B sin theta n cap. N cap unit vector whose direction is normal to plane containing vector A and B. Please don't get confused with this diagram. Actually this line of A cross B is normal to plane vector and outward. ये ऐसा है यहाँ पर ऐसे. But here we can't draw the line here. So we have taken a convention that whatsoever is normal to plane of plane of board, that should be shown vertical upward. If it is into, suppose you want to say B cross A, ये B cross A करना है आपने, यही है, तो B cross A will be downward. क्यों? Why? Because of the right-handed screw rule. When we rotate the screw, you can do this by having a screw rotating that. I will be telling example here. So, what is normal to plane of paper outward? That is shown this way. What is normal plane into it? Shown this way. In the coming chapters, any vector shown in plane of paper and that vector is normal and outward. So we put dots there, like this dot outward and cross inward. We will use convention this also. But here we have to understand A cross B. So A cross B here is normal to plane of board and outward. Not like this. It has been shown this way. When I was student, I was very much confused. And we were told with this angle 90, this then how it can be 90? It is 90 because it is like this. So B cross A normal to plane of board and into it. So they are in opposite direction. Vector. What is the example of this? Example of vector product. There are many examples. One example is there. Suppose it is x, y, z axis, na? X, y, or z. Sorry, x, y, and z. We can take like this. And here is the position vector of point of a body, which is moving with a linear velocity v. So momentum p equal to mv. And the position vector r. The angle between vector r, direction is this. So this is that angle. So r cross p करेंगे. Actually angular momentum पढ़ेंगे आप. R cross p. Here r and vector p are lying in xy plane. So angular momentum L will be normal to plane and outward along z axis. The vectors which come out as the product and the cross product or dot product, sorry, scalar vector product or cross product, they are in fact axial vector. Angular momentum L क्या है? Angular momentum. Angular momentum. So these are axial vectors. The vectors which come out as the product of vector product of two vectors will be axial vector, angular momentum. Force on moving charge in magnetic field, V cross B. V the velocity of charge Q, V the magnetic field. Suppose here in this class, magnetic field is like this and a charge party enter like this. So V cross B, the screw is anti-clockwise. When you rotate screw anti-clockwise, that comes out. So force on moving charge will be at right angle to B and V both, and here a vertical effort. So this video has become lengthy. I will take the properties of vector product in next video. Thank you.